So today is the day after Labor Day, obviously Tuesday, the 8th of September. My name is Scott Grizzard. I don't know why it's jumping like that. This is calculus. This is not calculus. This is, there we go. This is discrete math, lecture 3A. And today we're going to be talking about truth. Ooh, you know.
Fact. Not truth. If it's truth you're interested in, Dr. Tyree's philosophy class is right down the hall.
So today we're going to be talking about truth. We're going to kind of do a short, kind of an abbreviated introduction to a lot of this stuff. If you're really interested in this stuff, you want to take a class in the philosophy department, and it's important to note that you could consume an entire class, an entire PhD program on the subject of logic and truth and semantics and all of that stuff. And you could do PhDs in several different departments over the thing. So today we're just going to do a very brief introduction. And I want to make it very clear that what we want is to... There I am again. I'm not... I don't know why all of these things are all over the place, but they are. Okay. And I want to make it very clear that what we want to do is we want to talk about truth and logic in a way that directly is applicable to the computer. So we will do truth tables, even though I hate truth tables, you hate truth tables, and even Boole, who invented truth tables, probably hates truth tables. I think it was Boole. But we are going to talk about those things. So we want to talk about these things, what we mean. We want statements to be unambiguous and what we're going to mean by that. And we want to talk about these things in a way that relates it directly to the computer. We don't want to talk about them in some kind of airy, yeah, let's talk about truth, baby kind of way. We actually want to do them in ways that mean something when we code scripts. And we don't want to get like uber theoretical like the comp sci people do. They actually have to get a lot more we want like a practical application so that we can kind of avoid major mistakes at the margin. So that's kind of the goal. Now, a couple things. First of all, this is going to follow. Let me do screen 2 here. Let me close this so that I'm not revealing student information. Okay. So this is going to follow chapter 1 from Hahn and Koppler's. I really want to say Lexington, right? Because those are just great names. This is going to follow chapter 1 in Lexington. So yes, chapter 1 in Lexington is where you can find this stuff. Now, before we do something, before we do that, of course, we want to go over the quiz. Now, one thing, some of you have emailed me that there's a mistake on the quiz, and there is. There's a slight mistake in one of the answers, and I want to show you why these are happening, because now it's the second one. So I make this little quiz, and then I come down here, and just like a good instructor, I want to take the quiz for myself to make sure everything's good. So I hit this little preview button, and look what happens. You cannot do that because you are using Proctorio. So basically, if you think you hate Proctorio, I really hate Proctorio. I can't even preview the quizzes once I set them up. So that's the origin of this mistake. If you're wondering why those things happen. So let's go over this quiz. And I'll show you where that mistake is. And it's not really a mistake in the sense that the answer that wound up there was wrong. It just wasn't very good as an answer. It was technically a correct answer, but it wasn't very good. So let's go ahead and talk about the quiz. Okay, so the first question asked you to identify a bunch of subsets of the first thing. So what I was asking you to do was click the members of the power set. So what are the subsets here, right? There's, let's see, of B, right? Well, there's the empty set. that's in there. And I should say I just asked you to list them, so I don't actually need them as a set. So I have the empty set. I have the 4 of diamonds. The king of spades. These are all singleton sets. I'm going to put S there for spades. I'll try to draw it. Okay, I can't really draw. And then the singleton ace of spades. Know that the spades are the swords of a soldier. And then I have the doubles. And then I have the triple. So I could write the triple as 4D KS AS. But there's another way I could write the triple. Right? So I could write the triple as just B. Okay? So if I look here on the quiz, I could actually pull up the stats. I can pull up the stats if it does it. It takes forever. Hold on. So if I pull up the stats here, I can actually see that a lot of you missed this one by not selecting the B. Okay, so that was a common mistake. A lot of people missed it by not clicking on the B. Because B is a subset of itself. Okay? So how do we feel about that, 1 to 5? That B is a subset of itself. Okay. All right. So I could have written that as the whole triple or just as a thing. And of course, there was a thing where you select the subsets. Okay. All right. So A choose 3. Well, that's the 3-element subsets of this. Oops. I should do something to denote that this part is completely different from the others. So the 3-element subsets. Well, I got 4 clubs, 4 diamonds, K hearts, 4 clubs, 4 diamonds, ace spades. Four clubs, K heart, ace spade, and then 4 diamonds, K heart, ace spades. And notice something. When I'm enumerating, what am I doing here? I'm choosing I could have also said, right, this idea, 3 choose, I'm sorry, not 3, A choose 3 also equals what? How else could I have written these sets? I chose the 3 to include, but I could have chosen the each singleton to exclude, right? If this first one here, 4 club, 4 diamonds, king heart, I could have also said, well, it's the set A minus the ace of spades, A minus the king of hearts, A minus the 4 diamonds, and A minus the 4 clubs. So instead of picking the 3 to include, I could have picked the 1 to exclude. In other words, four choose 3 equals 4 choose 1. Right? Now, it's not the case, note. A choose 3 does not equal A choose 1. Those two things are not equal. Okay? All right. This was the one that I had the mistake on. So when I unioned these two things, I didn't mean to do this. The union of this should be the set 4 club, 4 diamond, K heart, AS. And then I throw in KS, the king of spades. But it's true that this is equal to 4 clubs, 4 diamonds, KH, AS, 4D, KS, AS. Those two things are equal since duplicates don't matter. But this is a bad answer. So that was my mistake. I put that in there. I accidentally put in the duplicates. It's technically correct, but it's a bad answer. I need to figure out a way that I can retake these things, that I can take these things and check for those errors. But I didn't. I'm sorry about that, but since it's technically correct answer, well, I'm going to let it stand. As I said, it's a bad answer, but it is a correct answer. Okay. A intersect B, so I want the things that are in both. So 4 of clubs is in A, but not in B. 4 of diamonds is in both. King of hearts is in both. No, sorry. King of hearts is not in both. King of hearts is in this one, but not in this one. The ace of spades is in both. And that's it. Okay. How do we feel about that? 1 to 5. The cup, the C and D, 1 to 5. Okay. All right. A minus B. That's going to be everything in A, but not in B. So let's see. 4 of clubs is in A, but not in B. The 4 of diamonds is in both, so it stays off. The king of hearts is in A, but not B. The ace of spades is in A, but it's also in B, so it's not in this thing. Likewise, this is going to be the stuff in B, but not in A. The 4 of diamonds is in both, so it's not. The king of spades is only in B, not A. And the ace of spades is in both, so that's it. How do we feel about that 1 to 5? Those two, D and E, together. This notion of set minus. One, the stuff that's in one, but not the other. Okay. And then A cross B is the set of ordered pairs, and there are 12 of them. The 4 clubs, comma, the 4 diamonds. The 4 clubs, comma, the 4 of the king of spades. The 4 clubs, comma, the ace of spades. The 4 of diamonds, comma, the 4 of diamonds. And notice I've got an ordered pair with the same thing. It's on both the X and the Y. The 4 diamonds and the king of spades. The 4 diamonds and the ace of spades. What's left here? King of hearts, comma, 4 diamonds, king of hearts, comma, king of spades, king of hearts, comma, ace of spades. Oh, what's left here? Thank goodness it's the last one. Ace of spades, 4 diamonds. Ace of spades, king of spades, and ace of spades, ace of spades. All right. All right, there's a question. Why wasn't A cat B 4 spades and king of hearts? You are thinking about the symmetric difference, I think, which is something to do. You are thinking about 4 divided sign. I'm sorry, A divided sign B, I think. 4 spades and king of hearts. No, there's no spades there. Oh, the 4 spades isn't up here at all. I'm sorry, you're not thinking that at all. Yeah, A intersect B or A cap B is just the ones that are in both. All right, how do we feel about part G, 1 to 5? It's a good question. There's nothing wrong with that question. Remember, the smartest people ask the dumbest questions. That's why they're the smartest people. Which is why in seminar, I'm always determined to be the smartest person. Trust me, I ask stupid questions in seminars. It's one of the effects of being an older graduate student. You're not afraid to look stupid, right? You got over that. When you turned 30, you got over the fact that you look stupid. You're just like, yeah, I'm fine with that. You want to know more than you care about other people's opinion about you. It's one of the things that come with wisdom. Okay, the null set is part of the power set, but it's not part of the cross product. It's a good question. All right, A, is this true or false? Uh, 2A is false. Give me a counterexample. There's a counterexample. Let A equal, well, the set containing little a, B equal, well, the set containing little b. Then A minus B is, well, A. Right? Oh, there's a question, and I saw this question. This question was also asked. Let me go back to this real fast about A cross B. Yes, that is also a symbol for matrix multiplication. Well, usually you just slam the matrices together. but it's also used for the cross product of vectors. So the cross product of vectors and the cross product of sets have the exact same notation and mean something completely different. So that was one of the things that was confusing. And that's actually a common problem in not only math, but in programming. It's common to overload signs. And I mentioned this last time when I mentioned the division symbol. Okay. All right. So how do we feel about this first problem, 1 to 5, this part A? That's false. Okay. All right. Okay. For any sets A and B, A cross B equals A times B. That's true. Right? I take all of these ordered pairs, and that's just true. So B is true. B is true because what I'm going to do is take every element from A and cross it with every element from B. So let me do that. Let's ask this, okay? What is the size what is empty set cross A? No, so there's a question. Is the size of A times the size of B the same thing as the size of A dot B? And the answer is, what do you mean by A dot B? So some people use that for notation for things. Otherwise, it's not. So that dot symbol is used for multiplying numbers. And if you're programming, you normally use the star. So yeah. So just out of curiosity, what is this? Well, if I take the set of ordered pairs, if I take everything from the empty set and I cross it with everything from the A, what is going to be this? Well, what must the size of the empty set cross A be? And there's only one set with nothing in it, correct? Somebody's already got it on the chat. The empty set cross A must be the empty set because it's the only set with nothing in it. That's just to confuse you a little more. Okay, the next one. For sets A and B, A union B equals the size of A plus the size of B minus the intersection. That's true. I did an example on the thing. I did an example last time using cards. If you want, I think I put my Margaritaville card somewhere else. I'll have to break out another one of these here. Because I think my other set of cards is in the other room where I was prepping the lecture. So I need another set of cards. Are there any questions about that? Okay. And notice that I fixed the previous lecture bit. It now said previous lecture instead of first lecture, which was nice. Okay. Questions, comments, issues before I move on to the new stuff? Okay. So if you do have more questions, Noah can answer them in chat, or I will answer them, or send me a message. And so I think the person that's in stream chat asking, so if A dot B is not equal to A, the size of A dot B, it's a matter of notation. This idea of it's not A dot B, it's A cross B is the set. Okay? So the set is me taking all of the elements from A and crossing them with all of the elements from B. And I get a set. Whereas the size of A is a number. Dot, the size of B, is another number. So that notation dot refers, in this case, to the to multiplying two numbers together. It doesn't refer to something that we're doing to sets. So the sets don't really merge. What was the rule then that I put in the previous lecture? It's not real. The smash is more of a merge, or the union is more of a merge. Here it's not really a merge. It's a new object. That's not really a merge. It's something new. It's we're creating cross products. But that doesn't make what you said stupid. It's not. What you're trying to do is figure out what the stuff you're talking about is. And this stuff is hard. I mean, these dates on these guys are 20th century, some of them. Okay? This stuff, math has been around for 2,500 years, and the dates on these people are within the last 100. This is hard stuff. So don't feel bad. Okay, so the question, let me actually address this question because it's a good one. It really is. The question is this thing, A dot B. This right now we don't have a meaning for. Whereas A cross B is the cross product. And in particular, for us, it's the set cross product. Okay? So this is a set. This is another set. This is a set. And this is another set. It is totally possible that I wrote my notes wrong. Okay? That is totally possible. Do you have a... Now, so that is correct. Now, if I take the size of A cross B, okay, this is a set, this is a set, but together, this is a number. Okay, it's a cardinal number. As a matter of fact, it's less than infinity, so it's for us right now, we're doing cardinalities that are finite. Okay. Whereas this is this right here is a number. Number. Right? But these are two numbers. And I multiply so I multiply numbers, but I cross product sets. Okay. Now, it's entirely possible that I messed up the notes. Let's see. I already found, by the way, I found a mistake in the notes for the week prior, and I posted updated ones. One of the formulas was wrong. Let me see here. Okay. All right, so it's in the previous notes. Yeah. So you see here, this right here is a number, whereas these two, I'm sorry, these two things are sets inside the thing. Okay? Whereas the thing outside, when I do this multiplication, I'm multiplying two numbers. Okay? So how do we feel about that difference, 1 to 5? Let me ask the whole class. How do we feel about that, 1 to 5? All right. Okay. And it's a subtle distinction. If you're having trouble with it, please come talk to me. I want to talk to you about that. We're kind of running a little on time, but I want to talk to you about that. If you're having an issue with that subject, please come talk to me. Send me a message on Discord. I will be happy to talk to you about it. But since a lot of people now have it, I'm going to move on to the next subject. But don't feel like you're stupid. This stuff is hard. Remember, simple is not the same thing as easy. This stuff is simple, but it's hard. So if you're having trouble getting it, we need to talk about it. And some people are saying they understand differently. Let's talk about it. We should talk about it, but they're two different data types, right? So that's one way to think about it. Okay. Um, okay. So let me move on. Again, if you have questions about this, please come talk to me. Ask in chat. That's fine. Maybe someone can help you, but I do need to move on here, and I've said that already. So today, what we want to talk about is we kind of want to get at this logic stuff. And again, Leibniz is famous from calculus. Leibniz was kind of the first modern kind of creator of a lot of this notation and some of these ideas. Of course, these ideas go back to Aristotle, but really formalizing them, that was Leibniz's first thing. And you'll remember Leibniz is also famous for being, inventing calculus along with Isaac Newton at the same time, and them yelling at each other. But it's important to note that Leibniz did a whole bunch of other stuff in math. Newton did a whole bunch of stuff in physics. And we've got people like Boole, and you can see these dates, right? These dates are 18th century, 19th century, 19th century, 20th century. These people that are working here are actually working, within the last 300 years. This is, math is much older, and actually getting at what truth is in a mathematical sense is a relatively, if you think about something, a field that's 2,500 years old, getting at these things is not that new. I mean, it's not that old. It's kind of a newish thing. So if you have trouble, by all means, let's talk about it. If you have trouble, don't feel stupid. This stuff is hard. Simple, but hard. All right, so what do we mean by x equals 4? Of course, I have this great quote from The Hobbit. If I say x equals 4, what do I mean? Do I mean that I'm taking this thing called x and saying, now, from now on, x is 4? Or am I taking this thing and I'm asserting the fact, as in, is it true or false, x equals 4? Right? Am I saying, let x be 4? So this question is actually a thing. Am I saying, when I say x equals 4, am I saying let x be 4, or am I stating 4 is stored in x, which is up for debate? What am I doing when I say x equals 4? Okay. And that's actually a question. This is a hard thing. Okay? It's not just what am I saying? And when we do PHP coding, what we want to say matters, right? Because if I say x with an equal sign 4, I'm assigning 4 to x. However, if I write x double equals 4, I am comparing them. All right? And this is actually a very good question. What am I doing when I say x equals 4? Am I making a declaration which can be true or false? Or am I asserting a value? Or am I assigning a value? Am I assigning x? Am I assigning 4 and storing it in x? So, how do we feel about the question 1 to 5? This idea that I'm actually saying two different things. Okay, and it could be either one. It's ambiguous. When I say x is 4 or x equals 4, I've got a little ambiguity there. So let's talk about that ambiguity, because we don't want that ambiguity. On the one hand, I could have an assignment. Okay? So on the one hand, I could do an assignment. So let's do this, and let's do a little table here, right? So in language, I would do let x be 4. Okay? In notation, on paper, I would do x dot colon 4. In PHP, I'm going to say x equals 4. Now, here's the kicker. There's also a comparison. The thing x represents right now is 4. In notation, I would say x equals 4. In PHP, I would say x double equals 4, which is annoying, right? Because, I mean, if I'm talking about code, I mean one thing if I use a single equal sign. If I'm talking about just on paper, I would use something else. How do we feel about that 1 to 5? That when I'm talking, I may mean two things, that I have to be specific, and that if I write it in code, in PHP code, I might be meaning something totally different than if I wrote it on paper. Completely annoying, isn't that? Or 4 is assigned to X. This comparison thing is really a true-false statement, while the other one's more an assignment statement. Okay. Now, for our class, we're going to have these things. We're going to call these things statements. And let me make sure I'm using the exact same terminology that's in the book. So again, this is mostly in the book, in that secondary textbook that I put online. Again, we are going to use that other textbook that you spent money on. Hopefully not too much because you bought a used version. But that textbook that we used online, let me see. That's not it. That's not it. That's not it. Variables. I don't care. He calls them propositions. Okay. Okay. So yeah. So that's the question. So someone's put in the chat, am I talking about substituting value in a list? Sort of. We'll get to that. Okay. So I have this thing. So I'm going to call something a proposition. And I'm going to say this. For our class, a proposition is a statement that could be true or false. Okay? Now, that's basically what I want. So, things that can make things not a proposition. Okay? Okay? Not. If I say X is greater than 4, it's not, because I don't know what X is. I'm going to use the word initialized. When I say initialized, by the way, okay, math people would call that's a programming type of term. Math people would call that instantiation. Okay, they're two words that mean the exact same thing, and this is a very common thing in computer science and programming in general. You're going to find out that the math term and the programming term are different, and that sometimes the same term means two different things. So when we talk about functions, functions are going to mean something different in a programming sense than they are in a math sense. Okay, so every time this happens, I'm going to try to alert you about that, because it's a source of common error. This is Okay? This is x is 3. X is assigned to 3. X is greater than 4. Okay? So together, this is a proposition. Indeed, this is a proposition by itself as long as it follows this. Okay? Because this can be true or false. No, it's false. I'm not stating it is. Right? Here I'm saying x is 3, and now I'm saying x is greater than 4. That's false. False, but a proposition. Okay? It doesn't have to be true. Okay? So together these things are a proposition. Alone, x is greater than 4 is a proposition. As long as it follows x is assigned to 3. As long as I've said what x is, that's important. As long as I say what a variable is, I'm good. 1 to 5, how do we feel about that? How do we feel about that idea that something can be false but still valid as a proposition? You know, it's still a proposition, it's false, but I can evaluate it to true false. That's the point. This I cannot evaluate. Okay? Let's talk about another one. What else is not a proposition? How about this one? X plus y equals 1. Okay? Not a proposition. Correct? What is X? What is Y? Don't know. Not a proposition. For every X Y on the unit circle, X plus Y equals 1. That should be a square, by the way. Do you see the difference? Here, I've told you what XY is. Fine, you don't like unit circles. For every sides of a right triangle A, B, and C, where C is the hypotenuse, a squared plus b squared equals c squared. Okay. Okay. For every, here's another example of this. For every x in the deck, x is red. All right? So for every card in the deck, that card is red. It's false, but it's a statement, right? I've defined what x is with a for every statement. Right? I know what x is because I said so. Here's another one. There exists an x in the deck so that x is red. Right? This one's true. Right? Is that true? Is there a card? Does there exist an X in the deck that is red? Well, it's not that one. Oh, that one is. Okay. So how do we feel about this difference, 1 to 5? This idea that these are not statement because I have uninitialized variables, but these are. Okay. Now let's go into problem set 2. All right. So let's go to problem set 2 here. Let me pull up Notepad here. That is problem set 3. All right. So if I look at problem set 2 here on Notepad, here, these are declarations, right? I've got var1 equals 5. I've assigned var1. I've assigned 5 to the value var1. I've assigned 3 to the value var2. And I've assigned the string pokey to var3. These are statements that assign. Now, here is a comparison statement. If 9 equals var4, so if I evaluate this, I'll either get true or false. So how do we feel about those two things, 1 to 5? By the way, the concepts, there's someone saying that the concepts are easy. The concepts are simple. They aren't easy. If you've never seen them before, they're not easy. They're just simple. Simple and easy are two different things. And I keep saying that. I say it all the time to the calculus people because some of this stuff is hard. Okay. So don't feel bad if you don't understand it. Just talk to me or talk to each other and then look to understand it. But don't feel judged. Now, this right here, it is an assignment. It's an array assignment, but I've said that this list here is the list Looney Tunes. Okay? Now, here I'm printing out the first Looney Tune. Now look at this statement. What is this statement saying? Here. This statement is the same as that for every statement, right? This statement, if I pull up the notes here, notice how this right here corresponds to this idea here. So X gained its context from this for each. So in PHP, so do you see where that context came from? So if I want to do this in PHP, the key idea is this, right? The statement, the words for each Looney Tunes as X is the same as for every X in Looney Tunes. Okay? And then it loops through, right? So if I say this, if I say Looney Tunes equals the set Bugs, Daffy, Sylvester, and then I say for all X in Looney Tunes, X is a rabbit, right? This is false, but it's a statement. Right? Now, assignments are also statements, but we can get to that in a moment. Right. So the loop goes through. Now, if I wanted to write code to evaluate this, I'd have to have, a list of rabbits or some kind of property of a rabbit, of bugs that would call it a rabbit. But this right here together is a statement. I assigned Looney Tunes and I initialized X through the for each or for all. How do we feel about that 1 to 5? Yes, so someone's mentioning in the thing that database is helping you keep up. It should be. This class, database, and the Java programming class are supposed to kind of go together. Okay? So they're supposed to be feeding off of each other. This class is supposed to help you understand the database. It's supposed to help you understand the Java, and vice versa. Okay. So they should be feeding off each other in a sense. In a sense, they really should be co-requisite, although they aren't, because the department thinks assigning you 3 co-requisite classes in the exact same semester is kind of mean. But they are supposed to help each other. I see the unanswered question there in Discord, and I'm sorry. But that's kind of the idea. Now, so statements. Statements are things that could be true or false. Okay, so some special types of statements. So there are some special types of statements. There are things called assignments. 434. Okay, I got 15 minutes. I'll make it through some of this. Assignments. Okay, stuff like x equals 5. X is assigned 5. Always true. Okay, so we're calling those a special type of statement, right? So if I say if I say in PHP x with a single equal sign equals 5, right? It's going to assign x to 5. It will always return true on that statement. Okay. Are there any questions about that? This is just special. Okay. We don't actually usually, as long as valid. Sorry. So as long as these statements are valid, we evaluate them as true. Valid, meaning I haven't tried to do something illegal like assign a variable something that's not a set. Okay? So things that are invalid. If I say A is the set of all sets, that's invalid because the set of all sets is not a set. So this is kind of a thing, right? And as long as the assignment would run, I call it a thing. As long as what I would assign could be a set in math. In computer, it means that we have enough memory and all that to do it. Okay. So what else? Okay. Ways, I should just say special statement because there's only one that I'm going to talk about. There are others, but I don't care. I'm going to talk about the one that's here. Okay. Ways to create variable. The first is with an assignment. I'm now using the word statement. Did I want, what am I calling it? Let me just make sure I've got it. No, proposition. I'm sorry. I'm trying not to use, sorry, this should be proposition. Uh, um, Is that the only place where I said not a proposition? Yeah. Okay, sorry. Statement is the word that we would use in math for this. I'm sorry. Proposition. Stick to the book. Sorry about that. Okay. With a quantifier. And the valid quantifiers are for all or for every. And there exists. And those are our two valid quantifiers. Okay. All right. Are there any questions about those things? 1 to 5, how do we feel about that? I could create variables with these things. For example, right? These are both valid. Right. Both valid. One is true, one is false, but both are valid. Okay. All right. So now we've got propositions. Let's talk about compound predicates. Yeah, predicate. Where did I say that word? Yeah, so I need a predicate. I need something to come after it. Sorry. Okay. I don't think I'm going to make it to everything I wanted to today, but let's see what else we can get to. All right. So we've talked about declarative instantiation or, creating a thing. We've talked about quantifiers. Let's talk about the scope of a variable. Now let's skip the scope of the variable. I don't want to talk about it. Let's talk about connectives. Okay. Now, there are a couple, and I'm just basically going to be able to list them and then do kind of their truth tables to start with, and then we'll have to pick this up next time on Wednesday because I'm Thursday because I'm a bit out of time. So let's talk about the connectives and their symbols. So let P and Q be propositions. Okay. And they could just be predicates because I could put them inside propositions. And I know I haven't really defined what a predicate is, and I kind of don't want to. I just kind of want to do this. So let P and Q be propositions. Right? P and Q is read P and Q. P or Q is red. Oh, P hat, P wedge, whatever. P or Q. Not P is red. Not P. P implies Q. And P bijection Q. I know on one I've kind of degenerated into lowercase. Or P if Q. By the way, this little last thing here, P if and only if, P if Q, that's a very powerful little piece of thing on the Scrabble board. That is actually a word. You can look it up. I will do so now. That is an actual word. If. Let's see definition. There it is. We can Google if and dictionary. Look at that, dictionary. We get an actual word. It's the conjunction in logic that means if and only if. If. That is an actual thing, and you can pull it up in the Merriam-Webster dictionary, and you can use it on the Scrabble board if you're using the extended Scrabble board. And now we have a mouse. Oh, shoot. Now I can't use this picture because it's got ads. Oh, well, I'll have to delete it. Okay. Are there any questions about that? Okay. Now, the way that a truth table works, I'm out of time, but let me just introduce this idea. Because this is what you're doing in the code for this week. Okay? So in the code for this week, you're going to be generating a truth table. So this is how it works. I take the proposition P and the proposition Q, and then I take P and Q. Okay? And then I ask what goes on in each case. If P was true and Q was true, then P and Q is true. So if I say I am going to the grocery store and I am going to the movies, and both of those things are true, then the statement so I go to the store, or I am going to the store. I go to the movies. Now, if both of these things are true, is it true when I say store and movies? Right? If I went to the store and I went to the movies, then it's true that I said I went to the store and to the movies. Now, if it's true that I went to the store, but false that I went to the movies, then is it true that I went to both the stores and the movies? No, that's false. If I didn't go to the store, but I did go to the movies, is it true that I went to both the store and the movies? No. And then if I did neither, is it true that I did both? How do we feel about that 1 to 5? I know I'm out of time. Just give me a little bit longer. 1 to 5, how do we feel about that? Okay. And as I said, everybody hates truth tables, but we got to do them. It's in the contract. It's on the list of things that I absolutely have to cover. All right. I'll fix that later. Now, let's do the exact same thing, but let's do the disjunction. PQ, P or Q. Now, if I went to the movies and I went to the store, is it true that I went to the movies or I went to the store? Now, here's something that's a little different in natural language. If I said I'm going to the movies or I'm going to the store, and then I said I went to both, you might say, well, wait a minute. You said you were going to do one or the other. No, I didn't. I just said I was going to do this or I was going to do this. But I didn't say I wasn't going to do both, right? This is not an exclusive or. Right? So I got in a wreck. I got hit while I was driving down Fowler. Oh, this was about 3 years ago. And the lady who hit me sued, right? So I'm going in there for my deposition. And my lawyer tells me as I'm walking in, she says, okay, Scott, don't answer anything except what he asks. Okay? And I'm like, I'm a mathematician. I could do that. So we get in there, and then the opposing lawyer says, okay, can you describe in your own words what happened? I go, yes. Can you describe in your own words what happened? Yes, I can. He asked me, did you stay off your cell phone or were you talking on it? Yes. Yes. You know, one of those things was true. Or both. So again, logic's a little different than natural language. It was the funniest thing, right? Because we're done with this, and the lawyer is getting absolutely furious, right? We're done with this thing. We walk out. My lawyer is sitting there the whole time doing this. And she gets out. She's like, that was awesome. That's what I'm talking about. Volunteer nothing. So, you know. Language is like this in math, right? It's very strict. True or thing. By the way, if you write a statement, if this or this, it evaluates, the first one evaluates the true, it will never evaluate the second one. It will just say true and spit it out. Okay. True, false. Evaluates the true, right? I did one of them. False, true. Evaluates the true as well. False, false. Evaluates the false. All right. So we started truth tables. I didn't make it to functions. I'll probably finish truth tables next time because some of these are a little bit different. Not P, of course, is an easy one. And next time we will actually define what a function is. I wanted to do what instantiation was before I defined a function. But next time we will finally get to functions. Finish truth tables and finally get to functions. Now, announcements. Next week, next Friday, is the exam, is the first test. I will post a study guide. But when I post a study guide, the point is think, this is important, think quizzes. Okay? I cannot state this enough. Think quizzes. The test is next Friday, the first test. Think quizzes. Okay? I cannot stress this enough. Think quizzes. Think of it as a really long quiz where I take a bunch of the questions that I asked on quizzes, put them on the test, change a few of the numbers and do that. If you understand the quizzes, you will do well. I will be posting a study guide, but think quizzes. Okay? That's the first thing about the test. The second thing is that I've spoken to you about a couple of you, but make sure you have an external web camera. Because we're checking like every 5 of the, we're randomly checking the videos for Proctorio right now, right? Because Proctorio's got the thing and then it flags a bunch of stuff. And then we check we check most of the flags and then we check like 1 in 5. Okay. For the exam, we're going to be checking every single one of them. So make sure on the exam that you understand the rules of the Proctorio and everything, because we're actually going to flip through the videos. We watch them in highly accelerated time, right? We don't actually spend an hour. Oh, by the way, on Proctorio, please wear a shirt when you take the quizzes. Just please do. Because remember, they are being reviewed. It's not just an artificial intelligence thing. So that's what we're going. So those are the 2 announcements. So this time we talked about truth values. We got through truth tables. We started truth tables. Next time we're going to talk about the finished truth tables, and we'll finally get to what a function is. No laptop cams. Okay, yeah, so no laptop cams. You need to have an external web camera that sees your whole space. If you have issues with that, please contact me. We'll see if we can figure out something. Maybe we can make it so that if you stand up the laptop in a certain way, it works. Maybe we can use your phone if you absolutely cannot get a webcam. But you need to talk to me about it first. And please get a webcam. Also, so if you have a webcam that can see your whole space, you can actually point it down. You put it up high enough so that it sees both you and your workspace when you're working on scratch paper. You will be asked to move around the camera, so it's important that you can't have Post-it notes on the walls. Also, remember that you have to take the exam at a particular time, at the time it's allotted, and you need to be on Discord at the same time we're taking the exam. And you need to be on Discord on your phone, not on your computer, which Proctorio wants exclusively, on your phone, so that if there's a problem, you can contact me or one of the TAs that'll be in there, and we can fix the problem right away. It can see your face if it sees all else, but it can't if it's a laptop. You need to have a computer thing that you can point a little bit farther away. So the best way to position that thing is just slightly to the right of your screen so that it sees your face, but it also sees your workspace. So it's kind of slightly to the right, slightly behind. Okay. Like here, you notice how I don't have the webcam facing straight on, like on the top. I have it on the side so that when I'm looking kind of at the side of my computer, I look straight at the camera. That's kind of the idea. So that it sees kind of a diagonal. I know you can't see my workspace, but I could position it so you could. But that would screw up the green screen, like the green screen's not already messed up. Any questions about that? Okay. If you have particular questions, send me that. There's an excellent question in Discord chat. I will be happy to talk to you about that. And stuff. Can I use, yes, people have used mirrors in the past. I will post kind of what I want to see. Any other questions? I know you all are really concerned about that. If you have issues, we've got 3 more quizzes ahead of us before the exam. We can work it out. All right. So that's it for today. I will now I'll get on. Someone has asked me, can I hear your audio? Can you hear our audio? No. Let me see here. Let me make sure I did everything. Isn't like conditional set? Yes. Like conditional statements. Okay. So not this Friday. Next Friday is the exam. All right. If you have questions, I'll be on a Discord for a little bit. But I do need to help someone else. Okay. That's it for me. Goodbye, everyone.